Hi, my name is Joshua Chin Jun Yang. I'm from FICT studying computer science, and I will be presenting my final year project 1 entitled Low-Cost Haptic Device. What you'll be seeing next is my slides. So Low-Cost Haptic Device is the main title of my project. And one of the biggest reasons we are doing this project is because we are lacking cheap and functional haptic device technology in the market, and it is pretty difficult to implement a haptic device as an individual at our homes or as a hobbyist. As such, there is quite a lack of progress in the research of haptic device, and we can actually compare this to the advancements in robotics, as there are hobbies and multiple groups of competitions such as Lego robotics that are promoting the progress of haptic device research, robotics research. The objective of this project is to study the design and technology of existing haptic devices, and as such, we can propose a simpler design of a prototype haptic device, and we will be validating the proposed design through actually building up a haptic device of our own. After going through the current design, this is the major design philosophy for all current haptic devices, and it is through a human and machine. It acts as a human machine middleman to communicate, so that we can actually experience and touch virtual objects in reality. Some of the most notable haptic devices now is such as the Phantom Omni. It is made by 3DS Systems, but at this moment 3DS Systems has been purchased by other companies, and you can still request for a demo unit through their website, and the rough estimate is about 10,000 USD. But the cost might have reduced as they went deeper into the research. Whereas another more notable and famous one is the Tesla glove. It is by VR Electronics, and you can also request a developer kit from them, but their estimate is about at $5,000 or $7,750. But I would like to also mention that these devices are not publicly available, and they are quite difficult to acquire as well, because you need to show them that you are trying to develop a program application or something using and integrating their devices for your program and enhancing the user's experience. For my design prototype, this is the flow chart for my design idea. It would be starting the software, and we will be selecting the interactable shape in the software. The interactable shape would be on a 2D plane for the time being, so that we will be moving the controller on our physical part, and then interacting virtually with the virtual shape on a 2D plane. And once the cursor is moving around and touching moving around in our physical space, it will also be updated live to the virtual space, so that we can see where our cursor is in accordance to our physical controller. And it will calculate to see if our virtual cursor is like crashing with the virtual object. and if it is crashing, it will trigger the motor response on our controller, and it will halt the controller's movement in that direction, and then it will continue to detect the user's point of interaction and movement. So if you move towards the right and then you crash into an object, you can no longer move towards the right side, but you can move upwards, downwards, or towards the left side. This is the current design concept for the controller. Because we are doing it on a 2D plane, so we are limiting the controller to limited space. And using a design such as this, we can connect the tubes, one near the controller and one towards the back of the box, so that it's more stable. And the red color user point is where our controller is at. It would be much like a joystick, but instead of pushing it with a thumb, you'll be holding it in your hand and moving it left, right, up, and down. And the controllers and the microcontrollers and modulators would all be attached to the side of the box, as shown at the Arduino and Raspberry Pi parts. And those parts would be where they'll be connected to our motors through cables along the tubes, and the motors will be responding to the user's input. This is the side view, dissected side view. The darkened parts are the wooden boxes, and the controller is attached to the tubes, as shown, for stability. The motors will of course be attached near to the controller for better motor controls. And this is the current controller design concept. To calculate the area, the range from to the side of the box, we are to calculate where we are attaching the ultrasonic devices onto the controller, so that we can detect, calculate where is the controller in correspondence to the cursor at every single point of view. And the bottom design is showing how is the tube extension supposed to look like. It looks a little small here, but it will be much larger as the ultrasonic module is quite huge as well. We will be having a half-built controller in the back. And this is the current circuit design we have. We are building two Arduinos to control to take into account the data of the ultrasonic, and using a Raspberry Pi as a modulator, so that we can tell the other Arduino that controls the motor responses how to respond to the human's motor control. And this is where we are implementing the design of the motor controls. And as you can see, the ultrasonic are being attached and are surprisingly large. And the center part of the circuit board will be hollowed out and be attached with the tube. The leftmost design is a prototype design for us to see how should we be building it. And this would be one of the structure board side. How are we going to be limiting the size? We're trying to build a 2-inch hole with a 2 by 8 by 2 inch hole, so that we can put the tubes across, and then we'll be prolonging it. The additional space would be removed so that we can make the box shorter and more usable. But this design may be changed in the future as motor controls are implemented to test out the whole system and its functionalities. The current plans I have for the future is to set up a control and virtual program synchronization so that I can like actually see that my cursor is working. And following up with that would be motor controls and to controller synchronization. And then we'll be testing out how the motor control functions. Of course, the expected results from this setup is to see where the synchronized virtual program with the controller, and then expecting that the motor control will be able to halt when we meet an object in the virtual program. And finally, the motor controls are supposed to be in sync with the virtual program. This project aims to be able to function minimally as a 2D space haptic device with force feedback. Hopefully, this design can be adopted by household hobbyists, and they can replicate and modify this design for future editions, and maybe even help improve the whole haptic device technology as a whole and lower the price. Ideally, of course, we can use this for education and perhaps even in space in the future, and hopefully it works. And as a conclusion, hopefully this design I have in 2D can be expanded to a 3D dimensions once we can use smaller microcontrollers and more efficient motor control system instead of just boxes and tubes right now, as it is not very effective and we are quite limited as a household project. Of course, hopefully we can also use 3D design to build a better structure for our haptic device instead of just woodworking, as having an expert in 3D design to consider various aspects would definitely help the articulation and the movement of the controller. These are the appendix a little bit to show the design currently, how it will look like when it's almost half set up. And that's all for my presentation. Thank you very much.